How do you do, ladies and gentlemen, and boys and girls? I'm Julius Sumner Miller once again, and physics is my business. And this time, our special business is the thermal expansion of stuff. Notice how I use that word. Thermal expansion of stuff, especially concerned with solids. Solids. Remember, to the best of our knowledge as earthbound creatures, all matter is either solid or liquid or gaseous. I say for earthbound creatures. There is a new kind of stuff now in the laboratory, as the British call it. Plasma, electrically charged stuff. And indeed, there may be stuff in a different state elsewhere, which travel to planets elsewhere and stars remote may reveal. But anyway, the thermal expansion of solids. A classical experiment which is not ever really properly explored, as we shall see. The classical ball and ring. Now, what do we do usually? We show that this is a brass ring and this is a brass sphere. They are metals. They expand when heated. We show that the ball cannot pass through the ring, the hole. This suggests very clearly two things. Either the hole is too small or the ball is too big. And because I'm a charitable man, I'll let you think whichever you wish. The hole is too small or the ball is too big. So now what do? We will make this a virtual demonstration and imagine its consequences. We heat the ring in a flame. We heat the ring in a flame of a Bunsen or Mecca burner. And if I do it long enough, I can then pass the ball through. Uh-huh. So somebody says, I understand that. The hole got bigger. The ring got bigger. Of course, these things may be true. Now, as all of you know, I am not so much interested in what we know as I am in what we understand. This is much more important. Accordingly, if we understand what has happened here, the following question can be answered. I have here some metal plates. Here is an aluminum plate with a little hole in it. Here is an aluminum plate with a little hole in it. Here is a plate. Here is a plate. It happens to be rectangular or square. It has a teeny-weensy hole in it. I can see the light. Question. Problem. I heat these plates uniformly. How could I do that? I could put these plates in the oven of my stove at home and heat them. So they are heated everywhere uniformly. Some of the plates are circular, some are rectangular, and they have little teeny-weensy holes. Question. When the plates are heated, what does the hole do? I'll give you some choices. One, the hole does nothing. That's a very good thing to have happen, because I plan in the future to do a lesson on relativity where we will see that Einstein took hold of an experiment whose results were nothing, and he made relativity of it. So nothing is important. So the holes do nothing. The holes get bigger. 3, the holes get smaller. Or I'll let you make that one smaller and that one bigger. I don't care the order. So, what do you think the holes will do? Do nothing, get bigger, get smaller. Now, I am led irresistibly to refuse to tell you, because it is more exciting if you engage yourself and your teachers and your classmates and your mothers and fathers and uncles on the question, what does the hole in this plate do? Oh, says some, say some, gets bigger. No, it gets smaller. So I'll tell you the best way to learn the truth of matters. Those of you who think one thing should get together with those who think the other and argue it out. And then, of course, you can do the experiment. One more exciting little dramatic investigation regarding thermal expansion of solids. Here is a ring of metal, a ring, and it has a diameter of its own stuff. Not welded or soldered or brazed, but part of the ring. let us say that this is a very good ring. A very good one. A very good one. And I put this in my oven and heat it. Question, does the ring stay circular or does it warp? Does it stay circular or does it warp? And would you believe it, boys and girls, I have gotten tens of thousands of letters regarding this little inquiry, in most of which the answers were wrong. But anyway, let's consider another. A bimetallic strip. Here is a strip of stuff brazed to another strip of stuff, and they are not the same kinds of stuff. Accordingly, they have different coefficients of expansion. I'm going to heat this bimetallic strip here in a flame and watch what happens. Watch. Look at that. Look at that. It is bending. Bending. Now, I'm prepared to tell you that one side is brass, and the other side is iron. And I want to know, did it bend on the iron side, toward the iron side, or did it bend toward the brass side? And so you see, I am raising some exciting little inquiries.